Hi and welcome to our mini lecture on graphing an exponential function and its asymptote. The function that we have in mind is of the form a times quantity b to power of x. Here's an example. F of x is given as minus 3 times 2/3 to the power of x. We want to graph this function and also graph its asymptote. So how is this problem different from the previous one? Just by a minor fact that here we have a multiple in front of our exponential term. Otherwise, it's pretty much same as the previous one. So let's see what's involved here. So I have a function f of x. It was equal to minus 3. Let me change the problem so that you do that one yourself, and I'm going to be doing this one. So let's say 4/5 to power of x. We do as we did last time. We are going to have a table. Of course, y is our f of x as far as your patience allows. So at a minimum, these are what's required by your software, but you want to go perhaps beyond that. Maybe look at 3, 4, 5 and so on. You remember b to power of 0 for a positive b is always 1. So 4/5 to power of 0 will be 1 times minus 3. So I'll have minus 3. 1. So I'll have minus 3 times 4/5. Minus 3 times 4/5. Next I have minus 3 times 4/5 squared. So simplifying that becomes minus 12/5. So which is approximately minus 2.4. And this is minus 3 times 6. This is going to be minus 3 times 16/25. And that is minus 48 over 25. Minus 1 flips the fraction, so it makes it 5/4. So I'm going to have minus 15/4, and minus 3 times the flipped fraction squared, so it's going to be minus 3 times 25/16, which is minus 75/16. So the next challenge that is left is to accurately find these points on your graph and show all of them. What is of significance here is the presence of this negative here. You notice that all of your y's are going to become negative. So what is that going to do? That is going to make your graph to be on the lower side of the page as opposed to the upper side, which would have been the case without this factor of minus 3. So at 0 we have minus 3, so we'll be here, then 1, 2, 3, and 1, minus 1, minus 2, minus 3. At least we go as far as 2. At the 1 we have minus 12/5, so that's going to be minus 2.4, so that's going to be here. Minus 48/5, that's going to be less than 2, and here. At minus 1 is going to be minus 15/4, that's going to be 3.75 almost, and this one is about 4.5. So I'll come here. So I have a collection of points like this, and when I connect them, I see a graph. Now if I patiently follow, go to 3, 4, 5 and so on, I'll see my graph approaching the x-axis. My x-axis is going to become asymptote. On the right hand side, in this case, the gap between the function and the straight line is going to approach 0, and for that reason that straight line, which has equation y equal to 0, otherwise called as x-axis, it's a horizontal asymptote for our graph. Same thing happens anytime where you have a, so a b to power of x. If I have a function y as a times b to power of x, if a happens to be negative and b happens to be less than 1, I'll get a graph that qualitatively speaking looks like this. What if a was positive? Let's go down here and try that again. So if I have y is equal to a times b to power of x, if a is positive and b is less than 1, I'll be up here, so all of my numbers are going to be positive, but as I go to the right I'm approaching 0. If I had y is equal to a times b to power of x, but a was negative and b was larger than 1, what would be the picture in that case? The picture is going to, so a negative means we are in the lower half because we are always multiplying by a negative number, and b being larger than 1 means it's asymptotes on the left hand side. If I have y is equal to a times b to power of x, a this time is positive and b is larger than 1, we have a picture that's going to look like this. So a is positive, I'm up here, and b is larger than 1 means the small side of the picture is on the left, and it explodes on the right hand side. So the important lesson to learn here is the difference between these four cases. So again, if a is negative, we are always on the lower side. If b is less than 1, I approach 0 on the right side. If a is positive and b is small, I'm positive, but since b is less than 1, I approach 0. My graph approaches the asymptote on the right hand side. If a is negative and b is larger than 1, negative a means I am in the lower half plane, b larger than 1 means I will be approaching 0 on the left and exploding on the right hand side. Finally, if a is positive and b is larger than 1, this is going to be the graph of exponential function in this case. Okay, that concludes this mini lecture. Until the next one, good luck and God bless.